In this video in our Chemistry of the P-block series, we are going to be looking at the reaction of chlorine with sodium hydroxide. Very common topic in the exam papers again, this one. Lots of questions every year being asked on it, and so it's important that we understand the reaction of chlorine with cold sodium hydroxide and also chlorine with concentrated hot sodium hydroxide. So let's jump into this. Right, let's talk a little bit about variable oxidation states to begin with. Now, this table looks rather overwhelming, but don't worry, I'm not expecting you to learn it. I just put it up there to illustrate what we know and what we need to understand. So -1 and 0 are the sort of common oxidation states that we tend to see for the halogens and halides. So for instance, any of the halides, F minus, Cl minus, Br minus, I minus, the oxidation state's -1. Obviously, we've seen HF, HCl, HBr, HI. That would also be an oxidation state of -1. With fluorine, it can join up with oxygen to form F2O, an unusual situation for fluorine, and that's oxidation state -1 as well. And again, we've also seen these substances at oxidation state 0 when they're in their elemental state. Any element is oxidation state 0, so F2, Cl2, Br2, and I2 are oxidation state 0. But as you can see, there's a wealth of other oxidation states that we can form with the halogens, which so far you have yet to come across. And some of these I'm going to list here now. I'm going to focus in on a few of them in a minute. So oxidation state +1. You'll notice fluorine, by the way, that's it for fluorine. It doesn't form, very rarely does it form anything above -1 or 0, but not so for the others. So chlorine and bromine, we can get oxidation state +1. For chlorine, we can get oxidation state +3. +4 is possible. +5 is quite a popular oxidation state for chlorine, bromine, and iodine. And we can form oxidation state +6 and even +7. And you'll notice the higher the oxidation state, the more oxygen is present within these molecules. So you can imagine that these molecules here, so much oxygen on board, they are very potent oxidizing agents. By the same token, the more oxygen that's crammed on board, the less stable these compounds tend to be. So that obviously leads to an increase in reactivity. However, we are going to focus on, in this section of work, on oxidation state +1. We find bromine and chlorine in this situation, but we're going to focus in on chlorine. And we're going to really look at HOCl or ClO minus. And we're also going to focus on oxidation state +5. And again, you can get chlorine, bromine, and iodine in this situation, but we're going to stick to chlorine. We're going to look at HClO3 or ClO3 minus. So these are the two areas that we're going to look at in this section of work. The rest, don't worry about it. I only put this table up there for illustrative purposes. No expectation on you to learn any of these formulas, save for the ones I just mentioned there, which we'll talk about in a second when we start looking at these reactions. Okay, right. So let's think of just chlorine and water to start with. I know this title of this presentation is chlorine with sodium hydroxide, but if we look at the simpler situation of chlorine with water, if we bubble chlorine into water to just make chlorine water, the sort of the way in which we have chlorine in the laboratory quite often, it forms two compounds in a reversible reaction. It forms some hydrochloric acid, and it also forms this HOCl compound. Okay, now let's think about what's going on here in terms of oxidation and reduction. So the chlorine, begin with, is in oxidation state 0. And in HCl, it's in a common oxidation state of -1. Now that process is a drop in oxidation state, so that means that the chlorine has been reduced in that process. However, if you look at the oxidation state of chlorine in HOCl, it's in a +1 oxidation state. So that means it's gone from 0 to +1. So that process is an oxidation. So this is a strange situation here. We're getting the same substance simultaneously being reduced and oxidized in the same reaction. And that's quite an unusual situation, and we have a name for it. It's a bit of a mouthful, stand by. It's referred to as a disproportionation reaction. A reaction where the same element is both oxidized and reduced in the same reaction. So, very common question in the exam papers is for you to bring up that definition of what a disproportionation reaction is, or to be able to identify one. So now you know, hopefully, when a substance is being oxidized, the same substance is being oxidized and reduced in the same reaction. Okay, so that's chlorine and water. So the title of this presentation is Chlorine and Sodium Hydroxide, and in fact when we take chlorine with cold aqueous sodium hydroxide, we find a very similar reaction takes place. The only difference being it's not so much of an equilibrium anymore. The sodium hydroxide drives the equilibrium to the right-hand side, so this is really not so reversible anymore. Form similar products though. Instead of HCl, we form Cl minus, and obviously we'd have a sodium as a counter ion here, or potassium as a counter ion, or some metal ion, and we'd form maybe sodium chloride, Cl minus, maybe sodium chlorate 1, this is a chlorate 1 ion, ClO minus, and we form HCl, H2O. So again, when we start looking at the oxidation numbers, we find chlorine going from 0 to -1 here, so it's been reduced. And we also find chlorine going from 0 to +1 here, so it's being oxidized. So chlorine with cold sodium hydroxide, we get a disproportionation reaction again, forming this sodium chlorate 1 or chlorate 1 ion, depending on the counter ion present. And in fact, we'll talk more about this in a second, but this is the main constituent of bleach. So this is how you would make some bleach. You would take chlorine and add cold aqueous sodium hydroxide to it. However, we can vary this reaction somewhat if we take chlorine with hot and concentrated sodium hydroxide. So the reaction changes somewhat now. We still get a disproportionation process going on. However, there's a different product. Instead of ClO minus, we form ClO3 minus. All the other products are the same. ClO3 minus chlorate 5 ion, the 5 indicating the oxidation state of the chlorine. So we've gone from 0 to +5 here. This is a highly oxidized state for chlorine to be in. And obviously it's been oxidized there, but this is a disproportionation reaction, so we've got a reduction going on as well. Now this sodium chlorate 5 or chlorate 5 ion is the main constituent of weed killer. So not particularly nice product to be formed here. Be careful with the balancing of this reaction, by the way. If you start playing around with it and freewheeling, you can actually balance the elements in a far simpler way than 3 to 6 to 5 to 1 to 3. But what you must remember is that the charges must balance as well. So we've got a 6 minus charge here, must balance with a 5 minus and 1 minus, a 6 minus charge here. So be really careful when you're balancing this reaction. You think you may have balanced it correctly, and it looks quite simple compared to this, but the charges won't balance. So this might be one where you want to just learn the balancing rather than think, oh, I'll just freewheel it in the exam and work it out in the moment. You may well make an error if you do that. Okay, so chlorine and water then just introduces disproportionation reactions to you. These are the two reactions that really feature in the exam. Chlorine with cold sodium hydroxide, an example of disproportionation forming chlorate 1 ions and chloride ions, and chlorine with hot concentrated sodium hydroxide forming chloride ions and chlorate 5 ions. Another disproportionation. So I mentioned to you that the chlorate 1 ion is used in bleach. So let me just talk a little bit about that. We know that chlorine is an effective oxidizing agent. We've talked about this in previous presentations. We know it's an electronegative element. We know it's good at pulling electrons towards itself. the electrode potential value when that happens is 1.36 volts. That indicates that it's an effective oxidizing agent. However, when we compare it to the chlorate 1 ion, we find that the chlorate 1 ion is even better. Pulling in 2 electrons, now we're up to 1.49 volts. We're not in fluorine territory here, but it is an effective oxidizing agent, a better oxidizing agent than chlorine is. It's better at pulling in those 2 electrons. And it's no surprise, therefore, that bleach, this is, I think, a picture of Domestos, bottle of Domestos. If you've ever bothered to look at the ingredients for bleach, this is what they look like. Disinfectants, sodium hypochlorite. Now that is the old-fashioned name for the chlorate 1 ion, ClO minus. Here it's paired up with a sodium counter ion. Sodium hypochlorite, sodium chlorate 1 is the main constituent in bleach. And here you got 4.5 grams of that in 100 grams of water, giving you just under a 5% solution. And that's what you find in bleach. So it works by stripping electrons off of the species. And so it'll decolor substances by taking electrons off them and bleaching them. Likewise, it'll kill bacteria by stripping electrons away from them and oxidizing them. And so this number tells us it's a powerful oxidizing agent. So to summarize then, sodium hydroxide with chlorine, you need to know effectively 2 reactions here. Chlorine with cold aqueous sodium hydroxide, forming this chlorate 1 ion, which is a main constituent of bleach. But also chlorine with hot aqueous sodium hydroxide will give you the chlorate 5 ion, and that's a main constituent of weed killer, although I don't think that is on the syllabus anymore, but it's an interesting fact nevertheless. For just 2 reactions, they feature a lot in the exam papers, so you really need to get your head around them and make sure that you can explain what is a disproportionation and use oxidation states in order to show that they are disproportionation reactions. So complete your booklet, have a go at the several exam papers questions that you see at the back of your booklet.